This will be for the con exercise, 2A tables, Venn diagrams, and probability. All right, so the definition of mutually exclusive. That means there's going to be no overlap. All right, it's going to be one or the other. Now, the formula for the probability of A or B, it's going to be the probability of A plus the probability of B minus the probability of A and B. All right, in other words, you add the two probabilities and just subtract the overlap. All right, if there is no overlap, if they're mutually exclusive, then you don't have to worry about it and you just add these two. All right, but if there's an overlap between A and B, you have to subtract it. This way you don't add it twice. A civics teacher asked her students to indicate whether they believed each of two headlines. One headline was false and the other was true, but the students didn't know this. The probability that a student selected at random believed the true headline was 90%. Probability that students believed the false headline was 82%, and 75% believed both. Okay, let's highlight that. The ones that believed the true headline was 90%. The ones that believed the false headline was 82%, and she said 75% believed both. In this sample, are the events believe the false and believe the true mutually exclusive? Well, we said mutually exclusive. We said it means no overlap. All right, in other words, it's going to be one or the other. Now, in this case, is there no overlap? In other words, is it one or the other? Well, that's definitely no. Okay, and why is that? Because it says right here, 75% believed both. Okay, so as far as mutually exclusive, the answer is no. All right, so for the first one, we'll choose no. And then the second question, the probability that the student believed the true or believed the false. Okay, it says find the probability that a randomly selected person believed the true or believed the false. So we said a minute ago, the probability of A or B is going to equal the probability of A plus the probability of B minus probability of A and B. Probability of A and B. All right, so in other words, we are subtracting the overlap. All right, so it's going to be believed true or believed false. And if we scroll up, how many believed it was true? We just underlined it a minute ago. The ones that believed it was true was 90%. And for the second part, the ones that believed it was false was 82%. And if we subtract the overlapping part, she found that 75% believed both. So we are going to subtract 75%. All right, so in case you missed it, what I did was I made the believed true part, I made that event A. And the believed false part, I made that event B. Okay, and then I just used the formula. All right, 90 plus 82 minus 75 is going to equal 97. Final answer, except they don't have percentage on the answer. So you just have to convert the final answer to a decimal. 97% is the equivalent of 0.97. All right, so that goes in the box. But you need to use this formula here. All right, 0.97. Make sure you use the decimal. 50 people were surveyed about their preference between chocolate and vanilla cake. The following table displays data for the sample. All right. In this sample are the events female and prefers chocolate mutually exclusive. Well, when you see the word mutually exclusive, that means it has to be one or the other. So ask yourself, can it be both? Can someone be a female and prefer chocolate? Well, clearly from the chart here, we can see the females that prefer chocolate are 15. So can it be both? Yes. So are they mutually exclusive? Mutually exclusive means one or the other. So the answer is no, they are not mutually exclusive because it can be both. All right, so that means the answer is no, they're not mutually exclusive. So select no, follow up, find the probability that a person is female or prefers chocolate. Okay, so we said a minute ago, if it's A or B, all right, probability of A or B. We're using the same formula. Probability of A plus the probability of B minus the probability of A and B. Okay, you have to subtract the overlap. So female will be event A, prefers chocolate will be event B. All right. So let's see here. So I'll rewrite it. Since A is female, we'll say probability of female plus event B is prefers chocolate. Probability that the person prefers chocolate. And we're going to subtract A and B. So in other words, the probability of both. All right, let's go to the chart. All right, probability that someone is a female. How many are females? Well, if you look at the females and you go down to the totals, 22 out of 50 are females. What's the probability that the person likes chocolate? Here's prefers chocolate. You go to the totals, 33 out of 50 prefers chocolate. And then you subtract the overlap. How many overlap? Female, chocolate, 15 out of 50. All right, so we have a common denominator. The denominator is 50. And if you do 22 plus 33, that's 55, minus 15, that's 40. All right, they actually don't make you reduce. So I'm just going to leave it as 40 over 50. All right. But again, all we did was add the probabilities and subtract the overlap. All right. You always divide by the total when you're doing probability. 40 out of 50. So the first answer was no. And this probability was 40 out of 50. Really, you can just reduce it and write 4/5 if you want. But I want to prove it to you. You don't even have to reduce it. All right, they accept the fraction. The usher at a wedding asked each 80 guests whether they were a friend of the bride or the groom. Here are the results. All right, so you can see bride, groom, and right in here, are the people that were friends with both the bride and the groom. All right, this right here is the overlap. All right, so this is a Venn diagram. Are the events mutually exclusive? Definitely not. Okay, you can see right there, there's an overlap. Mutually exclusive means no overlap. So that's a no. Find the probability that the person was a friend of the bride or groom. So this one is actually easy. The probability that the person was a friend of the bride or groom. If you look at the Venn diagram, there was 80 guests, so I know 80 is going to be in the denominator. How many were friends of the bride or groom? 17 plus 42 plus 20. All right, the reason I'm allowed to do that is because I only counted the overlap once. All right, if you count it twice, you're going to have to subtract it. So this is 52, 59, 79 over 80. Okay. Alternatively, since you see one person is a friend of neither one, you could have just done 80 minus 1 divided by 80. That's the same thing. 79 over 80. Okay, so bride or groom, 79 over 80. So the first one was no, and this is 79/80. All right. Employees at an office, what types of hot beverages they drank? 50% coffee, 25% tea, 10% both, drank both coffee and tea. Are they mutually exclusive? No, they drank both, some people. All right, so the first one is definitely a no. And then it asks the probability of coffee or tea. All right, so the same formula that we've been using. Probability of coffee or tea. All right, I'll abbreviate with a C and a T. How's that? Probability of coffee or tea. It's going to be the probability of coffee plus the probability of tea minus the probability of both. All right. In other words, T and C, same thing. Probability of coffee, well, they said that, let's see, how many drank coffee? 50% drank coffee. How many drank tea? 25% drank tea. How many drank both? 10% drank both, so you subtract. 50 plus 25 is 75. Minus 10 is 65. Converting to a decimal, you move it over 2 places. That's a 0.65. 0.65 right in the box. Okay, don't forget the decimal.